Hello there, this is video number 12, and this is for chapter 3, section 5. And this is about solving equations in quadratic form. So upon first glance, they may not look like they have anything to do with solving a quadratic, but they actually do. So let me actually write down the problems that we're going to solve this way, and you may see why they don't necessarily look like they're in quadratic form. So the first one we're going to do is 7x to the fourth plus 3x squared minus 4 equals 0. The next one that we're going to do looks like 9x to the fourth minus 25 equals 0. The next one that we're going to do is x plus 1 quantity squared minus 4 times x plus 1 minus 12 equals 0. The next one that we're going to do looks like x minus, oh, that's not a minus, x minus 11 radical x plus 24 equals 0. And the last one, I think it's the last one that we're going to do, looks like 8x cubed minus 27 equals 0. So none of these are exactly in the form ax squared plus bx plus c equals 0. But what you should know is that you can do X method on any trinomial where the power on the middle term is equal to 1/2 of the power, that's a p, power, on the first term. And so if you take a look at example number 1 right there at the top of the page, what we're talking about here is looking at the power on the middle term being exactly half of the power on the leading term. So you can use X method on problem number 1. Okay, so I'm just going to pop that in there as a method that we're going to use. Do you see how you could solve number 2? Some of you will probably see it right off the bat. Others of you may not. This is going to be difference of squares. This third one here actually might be a quadratic. I mean, it will be a quadratic when we're done. When you FOIL this out, you're going to get something to the second power. So we're going to have to just expand it and combine like terms. And then how can we solve a quadratic? You have 3 different methods, right? What are 3 methods of solving a quadratic? Well, one is factoring with X method. One is quadratic formula. And one is completing the square. Right? So any type of quadratic you can solve that way. Number 4 is kind of wacky, but because we already did rational exponents, let's see if you can follow where I'm going to go here with number 4. I have x minus, well, a radical, if you remember the rule that said you could write a to the m over n is equal to the nth root of a to the m power. So if we have a square root here, a square root of x is equal to x to the, there's no power on the x, so your m would be 1, and it's a square root, so that would be 2. So this would actually be 11x to the 1/2 plus 24 equals 0. And going back to what I just stated over here in black, you can use the x method on any trinomial where the power on the middle term is equal to half of the power on the first term. Well, this is a half, and this is actually 1. So we can x method this problem. Doesn't look like something that you can x method right off the bat, but you can, okay? And then number 5, excuse me, number 5 is a difference of cubes. And we're going to talk about how to solve the second half of that, right? So the whole goal of this entire class is for you to be able to look at an equation, any type of equation, fractional, rational equation, a quadratic equation, a linear equation, or radical equation. What else are we going to do? Logarithmic equation, exponential equation, all sorts of different things, and know how to solve these things. So you've got to be able to recall these methods that we're using. So let's go and do these. We're going to start out with number 1, the black one, 7x to the 4th plus 3x squared minus 4. So we're going to solve 7x to the 4th plus 3x squared minus 4 equals 0. And we can use x method because the middle power is half of the leading power. So nothing's really going to change until the final pieces of this. So this is a negative 28 and a 3, and you know how to do these. So this is 7 and negative 4. We have to divide by the leading term. This is what we're going to use here. This one becomes 1 over 1. So this will factor normally into x plus 1 and 7x minus 4, except if you were to actually FOIL this, you get x times x is x squared, and you need an x to the 4th. So all you have to do when you do these is make sure the power in the factors is the same as the power on the b term. Okay, so our b term has a squared, so these are each going to get a squared, and that's how, if you were to refoil, and let's just do that to show it real quickly, we would end up getting, we're going to have to come back to this, but I just want to FOIL this to check it for you and show you what's going to happen. Let me see if I can do this in a more organized fashion. Let's group these and just move this down. All right, and then I'm going to come back up here, and I want to take and just show you the FOIL this, how it's going to look. So if we had x squared times 7x squared, we get 7x to the 4th. X squared times negative 4 is negative 4x squared. 1 times 7x squared is 7x squared. And then 1 times negative 4 is minus 4. Combine like terms, and you get 7x to the 4th plus 3x squared minus 4. And this is what you started with right at the beginning. So that is the factored form. And remember, you can always FOIL and check it. But our goal here is to solve. So don't forget that when you solve, you have to take and set each factor equal to 0. Okay, so there's my two factors set equal to 0. And now I'm going to solve. And you need to utilize everything that you've learned up to this point. So we're going to move the 1 over to this side. X squared equals negative 1. I'm going to undo the squared by taking the root. And The root of -1 is I. So this becomes plus or minus I, and that's 2 of your answers. Okay. And then on the other side, I'm going to take and move the 4 over. So I have 7x squared equals 4. Divide by 7. So I have x squared equals 4/7. And then I'm going to take the root. So I have x equals plus or minus 2 over radical 7. And remember, you can't leave something that way. You've got to go ahead and rationalize this thing. So multiply by rad 7 over rad 7. And x equals plus or minus 2 radical 7 over 7. Okay? Now, I mentioned this before, but I just want to remind you, remember that you're going to have the same number of answers as the highest power. So the highest power is 4, so that means we should have 4 answers. And this is 2 of them, right? And this is 2 of them, because you have one is plus I and minus I. So we have I and negative I. Those are 2 answers. And then from this other box, we have 2 rad 7 over 7 and negative 2 rad 7 over 7. And so that's where those answers are coming from. And I believe in varsity, they leave you a box like this, x equals plus or minus, and then you fill in the box. So all you would have to put in would be the I. And then in the other one, x equals plus or minus, and you would put in 2 radical 7 over 7. Okay? All right. So there's number 1. The second one that we were going to do is, I don't know. I have to go back and look. All right. 9x to the 4th. Let me just number these on my paper. So this is 2. This is going to be 3. 4 is going to be that guy, and 5 is going to be that guy. Okay. So number 2. I need a different pen. Go here. Okay, so we are going to solve 9x to the 4th minus 25 equals 0. Now, I'm hoping by now you've done enough difference of squares that you're going to recognize this as difference of squares. I'm not going to go over how to factor that. You should know by now. So this is going to factor into 3x squared minus 5 and 3x squared plus 5 equals 0. Set each factor equal to 0. I forgot a squared up there. All right, so in both cases, we move the 5. So I get 3x squared equals 5. Divide by 3. So x squared equals 5/3. Then I'm going to take the root and take the root. And this is a plus or minus now. So I have x equals, and I'm just going to go ahead and rationalize right here. So I'm going to have plus or minus radical 15 over 3. Okay, this is all stuff we've spent time factoring. We've spent time doing radicals. We've spent time doing imaginary numbers. So if you don't remember how to do these things, I'm leaving it up to you to go back and find that information. We have it all. By the way, difference of squares is way back in chapter 1. It was 1.5 if you need to go back and look at how to factor that. Okay, the second part of this, we're going to move the 5. So 3x squared equals negative 5. Divide by 3. So I have x squared equals negative 5 over 3. Take the root and take the root. Well, I have a negative in here, so that's going to give me plus or minus I rad 5 over rad 3. Then I'm going to rationalize. So x equals plus or minus I rad 15 over 3. Okay? So there you go. Difference of squares. Just looks a little bit differently. All right. Number 3. This one was x plus 1 quantity squared minus 4 times x plus 1 minus 12. I feel like I don't even need to do this problem, but for those of you that need to see the work, I'm going to actually work it out for you. So we're going to expand this first and then combine like terms. Right? I mean, there's nothing for you to do here except do math. So we're going to FOIL out the x plus 1. Remember, that's x plus 1 times x plus 1, which gives you x squared plus 2x plus 1. Distribute the negative 4. Bring down the 12. And then let's combine like terms. So I have x squared. 2x minus 4x is minus 2x. Then I have negative 4 minus 12. This is a negative 16. Plus 1 is negative 15 equals 0. So you now have an actual quadratic in ax squared plus bx plus c form. And you could factor. You could complete the square. Which I think I'll do this just to remind you how. And then you could also do quadratic formula. And I'm going to tell you what, why don't you decide which one of those you're going to use? And then I want you to pause this video. And regardless of the method I use, I'm going to complete the square. But regardless of what I use, you should have the same answers at the end. So you decide, can you factor it? If you can, how, and do it. Complete the square or do quadratic formula. Okay, so pause. When you're done, come back, check your answers. All right, so I'm going to complete the square, which means I need to move this to the other side, put a blank in there. Oh, that becomes positive. In the blank goes 1/2 of b squared. 1/2 of 2 is 1. Squared is 1. So I get x squared minus 2x plus 1 equals 16. And then I complete my binomial square, which is x minus 1 quantity squared equals 16. Take the root and take the root. I'm going to move the 1 over. And then I'm going to go 1 plus 4 and 1 minus 4, which is 5 and negative 3. And those are your two answers for that. In my notes, I actually did this with X method. It was super straightforward. And I wouldn't complete the square or I wouldn't do quadratic formula if I can factor. That's always my first choice. I just wanted to review completing the square. I will complete the square all the time if my A is already 1 and my B is even, right? Because if it's even, then when I take half of it, it's not fractional, and it's kind of nice. Quadratic formula would be my last option. So I would actually do them in the order that I listed them there. Okay. Excuse me. Number 4, we're going to solve x minus 11 radical x plus 24 equals 0. And the way I did this in the front on the first slide is the way I would write this. I would go x minus 11x to the 1/2 plus 24 equals 0. And because this exponent is half of the exponent on the leading term, we can X method this. And the factors of 24 that would give us an 11 are 8 and 3. I don't need to do any division. I'm dividing by 1. So remember, when you do these now, your factors in here are going to get the power on the middle term. So this is going to get x to the 1/2 minus 8 and x to the 1/2 minus 3 equals 0. Now, if you were to FOIL these out, you'd go x times 1/2, x to the 1/2 and x to the 1/2. You add your powers, so you do get x. Negative 8x to the 1/2, negative 3x to the 1/2 gives you negative 11x to the 1/2. Negative 8 minus 3 is 24. So that does check. Now I need to set these equal to 0. And here's how I would go about solving these. There's 2 ways. Let me show you both of them. I'll do one way and one the other. You can leave the exponent as a half. Move the 8 over. And then if I want to get rid of an exponent of a half, I'm going to just square it, right? Use the reciprocal. So a half times 2 gives me just x, and 8 squared is 64. So that's one way to do that. The other way to do it is to convert this back into a radical. And then I go, and then you can square that, because that cancels that, right? And then you square the other side and you get 9. So whichever way you want to deal with that, if you prefer the radicals in there, you can certainly convert them. If you want to leave the halves in there, you can do that too. So both of these are going to be answers to this equation. Okay? So that wasn't too terrible. And then the last example in here, I think it is our difference of cubes. And this could be sum of cubes as well. I just happened to choose this one. So we're going to solve 8x cubed minus 27. And if you need a reference or formulas or anything, go back to chapter 1, section 6 for formulas. Even in your notes, right? In your notebook, you've got them written down. You don't need to go to the video, but that's where you're going to find them. So I know that I'm going to factor these by taking the cubes, and then I get a binomial and a trinomial. And the cube root of 8x squared is 2x. The cube root of 27 is 3. And then I'm going to square the first term, which is 4x squared, multiply the two terms, and then square the second term. And this whole thing is equal to 0. Sorry, I forgot that at the beginning. And then we're going to set these equal to 0 and solve. Okay, so I have 2x minus 3. I'm going to move the 3, which makes it 2x equals 3. Divide by 2, and x equals 3 over 2. Now, I have mentioned this a bunch of times, but until you actually have to solve one of these and need to know this, it doesn't really come into play. So this trinomial up here is never factorable, which means you can either use quadratic formula or you can use completing the square to solve. I think once again, I'm going to go ahead and just complete the square. So remember, our a term has to be 1. So I'm going to divide all these by 4. So I get x squared plus 3 halves x plus a blank equals negative 9/4 plus a blank. Remember that the blank is 1/2 of b squared. So this is 3/4. And you square the top, square the bottom. So this is 9/16 in both of the blanks. The point of that is now this is a perfect square trinomial, right? And we can take the root of the first term, the root of the last term, which is 3 over 4, and the sign off the b, which is a plus, and that's squared. And then we have to do the math on the right-hand side. So let me grab a calculator. I have negative 9 ABC4 plus 9 AB, that's not ABC, ABC 16. It gives me negative 1 and 11/16. So I'm going to hit second ABC equals, and that gives me negative 27/16. Okay, now I'm going to undo the square by taking the root. That's going to cancel that. And I have x plus 3/4 equals plus or minus I radical 27 over 4. See what I did there? The negative becomes the I. The root of 16 is 4. I haven't reduced that root of 27 yet, but I'm going to need to do that. And then remember that the constant over here is going to move over and get put in that place. So x equals negative 3/4 plus or minus, let's reduce the root of 27. So this is 3 radical 3. So I have 3i radical 3 over 4. And then knowing what we know about fractions, A over B plus C over B equals A plus C over B. I'm going to combine those things into one fraction and make it x equals negative 3 plus or minus 3i radical 3 all over 4. And that is the answer that I need there. So there's 2 of my answers. Here's one answer. This started out as a cubic, so I should have a total of 3 answers. And that's the way you're going to do that. All right. So there's only one more section in this chapter, and then we'll be talking about a test. So toodaloo for now.